And once again, we're going to be looking at solving inequalities. So make sure you have out your notes and you're ready to go. Alright, so what I want you guys to do first is I want you to solve these two warm-up problems. So write these down and go ahead and write down all the steps you would use to solve both the equation and the inequality. I want you to make sure that you show all your steps and all your work so that we can check to make sure that you're doing it right. Go ahead and pause the video now so you can work these problems out. Hopefully now that you've solved these, if we were to solve the equation, we would have subtracted 5 from both sides. And then added 2x. There, we would divide by -2, and x is equal to 3. Over here on the inequality, we would add 1. Notice, since we just added a number, the inequality sign stays the same direction. Here we're going to divide by 30. Once again, since we divided by a positive number, our inequality sign will not change, okay? Here we're going to go ahead and graph it. Since it's not a perfect number, we know that 5/3 is between 1 and 2. So we're going to graph 1 and 2, and then we're going to graph some on both sides. And we know that 5/3 is pretty close to 2, so we're going to go ahead and graph it there. But since this inequality is not including 5/3, our circle is going to be open, and we're going to be discussing that in just a few minutes. And x is everything greater than that, so we're going to draw our line facing that direction. Okay? Hopefully that is what you guys got. Notice that on the inequality, your value for x could be anything greater than 5/3, so it's not just one answer, whereas on the equation, it's still, your answer is just one number. Alright, we're going to look at making sense of problems. So we're going to be looking at some word problems in this section. So here, Max and Mary are taking a trip to the grocery store to buy some groceries. They know they need a gallon of milk, which will cost them $2. They also want to buy some candy. And they find the sale candy, and where the candy is $1 per piece. So we are going to write an expression. Remember, an expression does not have an equal sign, or in this case, an inequality sign, for the amount of money they will spend if the amount of candy they buy is C. So looking back up here at our problem, we're going to highlight the important information. So we know they have to buy a gallon of milk, and that's going to cost them $2. We also know they want to buy candy, and that the candy is $1 each. So when we're down here writing our equation, we know they have to buy milk. So that's going to be our $2. They're only buying 1 gallon of milk, so it's just $2. And they also want to buy candy. Well, we know the candy is $1, and we know that the amount they buy is C. So the amount of candy they buy is 1C, $1 per piece. So that is our expression. Then if we look down here, we want to go ahead and write an expression which has an equal or an inequality sign. So Max has $6 and Mary has 1/2 of that amount with her. So let's first figure out that. So if Max has $6 and Mary has 1/2 of that, Max has $6. Well, what is 1/2 of 6? Hopefully you figured out that that's 3. So together, they have the $6, which Max has, plus the $3 that Mary has. So they have a total of $9 together. So that's how much they could spend because that's how much they have. So that's going to be our maximum value. Okay? Can they spend that much? Yes. So that means the 9 is included. And we show that with the line under the inequality sign. So now we need to use the expression. So we know what they're trying to buy. So we're going to use the expression right here down here. So we're going to plug that in. So 2 plus 1c. So then we can figure out how much candy they can buy based on how much money they have and what they have to buy, which is the milk. Make sure you have all this written down before you move on. Alright, so now that we have that equation, or that expression, we are going to solve it. We need to figure out how much candy they can buy. So in order to do that, we're going to solve it just like we would an equation. We're going to subtract 2 from both sides, divide by the 1. So 7 is greater than or equal to C. So that means that with the amount of money they have, they can buy no more than 7 pieces of candy. But they can buy 7 pieces of candy. So we're going to go ahead and graph this. Since our inequality is including 7, we have a closed circle. It means that they can buy 7 pieces of candy. And then C is less than 7, so it's everything less than 7. So right now what I want you to do is I want you to write down three amounts of candy that they can buy based on what we just saw. Go ahead and pause the video and write down your 3 amounts. Alright, now we're going to look at open versus closed circles on our graphs. So if you look at these 2 inequalities, hopefully you notice that the inequality sign is a little bit different. One has a line under it. The one on the right has a line underneath the inequality sign. That means that is either greater than or less than or equal to. So it includes the value that the variable is representing. However, on the left, it does not include that value. So we're going to go ahead and solve these 2 inequalities. We're going to subtract 2. That gives us 6 is less than 6x divided by 6. And then 6 divided by 6 is 1. So 1 is less than x. Over here, we have the exact same numbers. So we're going to do the exact same thing. Here, however, 1 is less than or equal to x. So we have almost the same answer, but they're just a little bit different. If we go ahead and graph these, we're going to start with our value, and we're going to put numbers on both sides. Start with your value. Alright, let's look over here at the right. 1 is less than x. Since there is no line, that means that 1 is not included on our values. So we're going to draw an open circle. The open circle represents that the 1 is not included in our answer. So our answer could not be 1. It's just x is anything greater than 1. So 1, anything greater than 1. 1 is our absolute minimum value, but it cannot be 1. However, over here on the right, 1 is included, and that is represented by the line underneath the inequality sign. We represent that with a closed circle. Once again, all our values are greater than 1, but our answer can be 1. So there's a difference. This, on the right, our answer can be 1. But on the left, our answer cannot be equal to 1. Alright, now we're going to look at what happens to the inequality sign when we are multiplying or dividing by a negative number. So once again, these 2 inequalities are very, very similar. The only difference is that on the left, it's a positive 3x, and on the right, it's a negative 3x. So we're going to go ahead and solve these. So there we have 2 is greater than or equal to x. Over here, since we're dividing by a negative number, we have to flip our inequality sign. So here, negative 2 is less than or equal to x. We're going to go ahead and graph those. So over here, if we graph it, remember that this is including 2, so our value is going to be a closed circle. And it's everything, 2 is the greatest amount, so it's everything that is less than 2, but also including 2. Over here, once again, our value is including negative 2. But in this case, it's everything greater than x. So negative 2 is the smallest number on this inequality. Make sure you have this written down. If you have any questions over this lesson, make sure you're writing them down, and we will discuss them at the beginning of the hour.